ladies and gentlemen. We're going to do 8.3a today. We're going to be doing trig integrals. So we're going to be learning some new fun techniques for integrating trig functions. Sorry, brain and mouth aren't working. Today what we're going to do is sine and cosine, and then on the next day we will do tangent and secant. So as we get started, let's take a look at this integral. So what if I had the integral of sine to the fifth of x cosine of x dx? So that's kind of entertaining. So if I let u equal the sine of x, du is the cosine of x dx. So then this just becomes a simple u substitution, and I would do the integral of u to the fifth du. So it would just be u to the sixth over 6 plus c. Substitute my stuff back in, and I'm going to get the sine to the sixth of x over 6 plus c. So that one was actually fairly easy, and we already know how to manage those. And by the way, I'm sorry this is so late in the afternoon. My bike was calling me today. All right, so let's look at a different integral. So even though it looks very similar, what if it looked something like this? What if I had the sine cubed of x cosine to the fourth of x dx? So we might think that we could do u substitution, but if you think about it, if I let u equal the sine of x, du is the cosine of x, but there's those pesky powers. So we are going to get some new rules today, and they're a little bit entertaining, so I'm going to do one example per rule. And we'll get to this one in just a moment. So before we get started, we need to review some trig identities. T, that's a T. Alrighty. So the first one would be our Pythagorean identity, which is the sine squared of x plus the cosine squared of x is 1. And then the next one that we're going to get is one of our half angle identities, and I'll write that down in a moment. So sine squared of x is going to equal 1 minus the cosine of 2x over 2, and this is one of the half angle identities. And this one was the Pythagorean. Ooh, that's a long word. Okay. Then the next one is going to be for cosine. So I'm going to have cosine squared x, and it's going to be 1 plus the cosine of 2x over 2. So what I would recommend that you do is on that handy-dandy note sheet that I gave you, I would recommend that you write those three things down, and then we're going to get some guidelines. We're going to get 3 of them, and I would think that would be a good thing for you to write down as well. All right, so now what we're going to do is we're going to get guidelines. That's a D. For evaluating integrals that are going to involve, just like the one that I wrote right here, involving, so it's going to have powers, multiple powers of sine and cosine. All right, so for each rule, there's 3. I'm going to write one down, and then I'm going to do an example. And I think I can squeeze this first example in on the bottom of the page. So the first guideline would be if, the power of sine, it was cold out on our ride today, is odd and positive. Okay, so we're going to be looking at the given integral, and we're going to be evaluating, is the power of sine odd and positive. So if that's true, we're going to save 1 sine for the u substitution. And particularly, we're going to want it for the du. Okay? And then we're going to convert the remaining factors to cosines, and we're going to do that using our information up here. Sorry. And then we're going to expand and integrate. Alrighty, so let's do the example that I wrote up here. Okay, so I'm going to go ahead and rewrite it. So I had the sine cubed of x cosine to the fourth of x dx. So we notice that the power on sine is odd and it's positive. So the first thing that I'm going to do is I'm going to rewrite this. So I'm going to pull out one of my signs. So I'm going to write the sine squared of x cosine to the fourth of x, and then I'm going to write the sine of x dx. And that little guy is going to play together. So notice what I did. This was to the third power, and I just borrowed one of them and stuck it over here because I'm going to use this for my du later. Okay. Now what I'm going to do is I'm going to rewrite sine squared in terms of cosine squared because that's our second step. So, sorry, if I use my trig identity or the Pythagorean identity, sine squared is 1 minus cosine squared. So I'm going to rewrite this as the integral of 1 minus cosine squared of x times the cosine to the fourth of x, and then I'm going to have my sine of x dx. Okay, that's still all multiplied together. Alrighty. So what I'm going to do on this one, since I want this to be my du, I'm going to let u equal the cosine of x, but I'm not going to do that just yet. So now what I'm going to do, so I did this step, I converted the remaining factors to cosines, and then I'm going to expand and integrate. So this is where I'm going to expand, but I'm not going to expand this guy, okay? So I'm just going to manage these two pieces right here. So then this is an integral of the cosine to the fourth of x minus the cosine to the sixth of x times the sine of x dx, okay? Alrighty, and then what I'm going to do is I am going to distribute, but I'm going to split this up into two expressions. So this is going to be the cosine to the fourth of x times the sine of x dx, and then minus the integral of the cosine to the sixth of x sine of x dx. Alrighty, so all I did at this point was distribute. Well, now I'm going to do my u substitution, and I'm going to do the same substitution in each integral. So I'm going to let u equal the cosine of x. Well, then du is a negative sine of x dx. So in the first integral, I need to introduce the negative. So this is going to become the integral of u to the fourth. Oops, I got to get my little minus in there. I'll circle him so we don't lose him. Du. Right, because du is the sine of x dx, and then minus, same thing happens over here. If I let u equal the cosine of x, du is a negative sine of x, so I need to introduce a negative, which makes this guy positive, and then I have the integral of u to the sixth du. Well, now those are super simple, so this is u to the fifth over 5, that's a 5, plus, that guy's minus, I'm going to move my equal sign over. There's my minus. We'll circle him again. U to the sixth, u to the seventh over 7. Sorry, I'm all crooked. Plus c. And then I'll substitute everything back in. So I'm going to squish it in here down on the bottom. So my u was the cosine of x. So this is a negative cosine to the fifth of x over 5 plus the cosine to the seventh of x over 7 plus c. And then I would report my answer, well, the integral of f of x dx is equal to, and holy cow, from here to here. So it's really not difficult, but it is pretty laborious, and this process is going to take a little while to get used to. Alrighty? So again, today I'm only going to do one example for each particular problem because the examples are a little bit long. So then that way we will have plenty of time to work on this in class. All right. For our next example, for our next guideline, if I'm going to be consistent, then the next thing that I want to look for is the power of cosine odd and positive? So odd and positive is our key phrase this time. And just like last time, then I'm going to write some additional guidelines. So I'm going to save one cosine, just like we did with sine, to be used for our du. Okay. This time, since I'm starting with cosine, I'm going to convert the remaining factors. sine, and then I'm going to expand and integrate. So it's really the same basic process. It just looks a little bit different. All right. And I had to play with this for a couple of minutes because it just looked really weird to me. All right, so on our integral for this one, we're going to have the cosine cubed of x dx over the square root, that's the square root, of the sine of x. And you're going, oh, that's yucky. All righty. Coffee break. So we're going to separate our cosine, and we're going to save one to attach. So this is going to be the integral of cosine squared of x times the cosine of x dx, because remember, this is going to be my du in a little bit, over the square root of the sine of x. All right, so now I'm going to get rid of the cosine, and then I'm going to put it in terms of sine, which we're down to the second portion. So I'm going to have 1 minus sine squared x over the square root of the sine of x. And remember, this is just the Pythagorean identity, and as you can see, this is going to clean up and be pretty nice. Cosine of x dx. All right, so because I have something added on the top and one term on the bottom, I can separate this into two terms. So I'm going to write it as the integral of 1 divided by the sine of x to the 1/2 minus the sine of 4 over 2x divided by the sine of 1/2 x, and then put my little bracket guys in there so people aren't unhappy, and then here's the cosine of x dx. Alrighty? And I'm going to rewrite this again. I'm going to manage all of my exponents, so this is the integral of the sine to the negative 1/2 of x. And remember, I could write this as, here, I'll stick it over here on the side. I could write it as the sine of x to the negative 1/2. Either way is appropriate. And then I have 4/2 minus 1/2. So this is minus the sine of 3/2 x. All of this is times the cosine of x dx. Alrighty? So I'm going to distribute this guy, and I'm going to separate each term just so you can see what we're doing. Maybe I won't on this one because you guys are so brilliant. So you run circles around me, so maybe I'll just do it from here. So I'm going to let on this one my u equal the sine of x, and my du is going to equal the cosine of x dx. So remember, technically this gets distributed to both terms, and then I would separate each term. Okay, well, if u is the sine of x, then my integral, and then I have cosine of x dx, which is my du. I have the integral of u to the negative 1/2 minus u to the 3/2, and then I have du. Well, then this is pretty easy. This goes up a power, so I'm going to get u to the 1/2 divided by a 1/2 minus, and then go up. So minus u to the 5/2 over 5/2 plus c. Okay? And hopefully this wasn't too confusing by not rewriting it. And then I'm going to simplify. So this is 2u to the 1/2 minus 2/5, u to the 5/2 plus c. I'm going to substitute all my goodies back in. So this is 2 times the sine to the 1/2 of x minus 2/5 to the sine to the 5/2 of x. And then, of course, I can't forget my c because it is an indefinite integral. Alrighty, so that one wasn't horrible. If this is a difficult thing to see, don't skip that step. Then rewrite your integral, splitting it up into two, and then you can see your u and your du in each individual integral. All right, I'm going to write the rule, our next rule. I promised 3, so here's the third one, and then I'm going to need some space to do that one. All right, so the next thing that we're looking for are that the powers of both sine and cosine are even, oops, I forgot the E, even and positive and we are going to make repeated uses of the identities. All right, and just to rewrite a couple of them, because we haven't used them in a while, so sine squared x plus cosine squared x is 1, and then I know that the sine squared of x is 1 minus the cosine of 2x over 2, and cosine squared x is 1 plus the cosine of 2x over 2. So in this particular situation, you're just going to have to figure out a way to remember your negative and your plus, because now that you're in Calc 2, you're going to have to remember these lovely little things for your exam. All right, so the next example that we're going to do looks fairly simple, and then it gets entertaining. All right, so we're going to start with that cute little integral, and then we're going to split it up. So this is an even power of cosine, which puts us in this new category. So this is going to be the cosine squared of x, quantity squared dx. So then I'm going to rewrite this using the identity. So cosine is plus, so it's going to be 1 plus the cosine of 2x over 2 quantity squared dx. All right, so the next thing that I'm going to do is I'm going to expand this little guy. So this is the integral of 1 plus 2 cosine 2x plus the cosine squared of 2x all over 4, and then you have to put your little guys in brackets, dx, okay? And then what I'm going to do is I'm going to rewrite that and split it up into individual integrals. So this is going to be the integral of 1/4 dx, and then I'm going to have plus 2 divided by 4 is a half. And I'm going to go ahead and pull him out front. There's the 1/2 cosine of 2x dx. And then let me squeeze the other one in. I'm going to pull the 1/4 out front. And I have the integral of cosine squared of 2x dx. All right. So the first one is super simple. The second one is super simple. This one is where we have a little work to do. So the first one, if I had pulled that 1/4 out front, and then I have x, and then in the second one, I'm going to let u equal the 2x, du is 2 dx. I need to introduce a 2 on the inside, so I'm going to introduce a 1/2 on the outside. So I have a 1/4, and then it becomes the integral of the cosine of u du, which is the sine of u. There's my 2x. All right. This guy is the problem child, and we're going to have to rewrite him, and we're going to use this identity that we used right here one more time. So here's the fourth, and then the integral is going to become 1 plus the cosine. The identity says it's cosine of 2 times the angle, and since this already has a 2 in it, then this becomes 4x, and then I have over 2, and then dx. Alrighty, so this one's done, this one's done. Now I need to manage this. I'm going to take that 2 out front. So I have my equals there, 1/4 x, and then I have 1/4 sine of 2x, and then I have an 1/8 times the integral of 1 plus the cosine of 4x, and then dx. Okay, so if we think about our u substitution right here, I'm actually going to split this up into 2 integrals, so I think it'll be less confusing. So I'm going to have the integral of 1/8 times dx plus the integral of 1/8 times the cosine of 4x dx. That just looks nicer, okay? These two guys carry forward. So here's the 4th x, here's the 1/4 sine of 2x. This guy is easy. He's 1/8 to the x. And then this one, my u is 4x, my du is 4 dx. I need a 4 on the inside, so I put a 4th on the outside. So then plus 1 over 32. The integral of cosine is the sine of u, 4x plus c. Alrighty. Then I'm going to combine these two guys because they're both just x to the first degree. And so when I do that math, and I'm assuming you're brilliant, you can do that. So this is 3/8 x plus 1/4 sine of 2x plus 1/32 sine of 4x plus c. Whew! Alrighty. Those were the 3 examples that I promised. We will do quite a few of those in class tomorrow. So make sure that you add those 3 identities to your note sheet. And then you might also want to think about adding the rules for the powers of sine and cosine. Alrighty, that's it for today. I will see you tomorrow.